Hey guys, so in this Unity lesson we are going to go over just the basic lights in Unity and their functions and how they operate. So whenever you start up a new scene in Unity, by default there is a main camera and a directional light that is in the scene. The directional light is actually linked to the skybox if you're using one of the default Unity skyboxes. And so no matter what direction you move or rotate that spotlight, the skybox reacts to it by moving its sun in accordance with the rotation of that directional light. Now the properties of the different lights inside of Unity, all their properties are pretty close to being the same. So with the directional light, it has a color associated with it, so you can change the lighting color of the scene if you like. As a mode, which with real-time, mixed, and baked are your different options. Real-time just means all the lighting from that light is going to be calculated on the fly, so while the game is actually playing. Mixed, you can bake in some of the objects. Any object that is marked as light map static can have its lighting baked via that light, which is great. And then baked, which means that that light will not be live in any way. All the lighting that it's producing within the scene will be baked into a light map texture that is then applied to any of the areas or any of the objects within its vicinity that is static light mapped. So we're going to keep this real time. So with intensity, you can change how bright the light is. Indirect multiplier, this is useful when your scene is built out and compiled when you compile all the lighting for the scene. It basically serves as how much kind of bounce light there is in the scene. The indirect multiplier is kind of how much influence the light has even without being near other certain objects. So your shadow type, you can either have no shadows, hard shadows, or soft shadows, and you can change the strength of those shadows. Your resolution can be set via what your quality settings are. So under Edit, Project Settings, and Quality, you can actually change the quality of your shadows per whatever your user may want to play on. So if you export your game to be played on multiple different settings, you can change the shadow distance, its resolution, its near clipping plane, per whichever platform, or whatever platform, as well as whatever quality settings your user may want, depending on the how high end their system is that they may be playing your game on. So along with that, we're just going to keep that at very high resolution for now. Your bias is sometimes your lights will give you these little flickery lines all over your mesh, and that's because you need to up the bias level. Again, because this is all real-time lighting, Unity is trying to figure out how to be the most efficient with drawing these shadows. And sometimes it's not the most accurate, and things can get a little fuzzy. So you kind of have to roll with the punches on some of that stuff. Normal bias is, again, pretty similar. It's looking at your edges and whether or not there's any type of light leaking, and how you want to control that. So the higher I make my normal bias, you can see that some of this light is actually leaking through my 3D object. So if I keep that a bit lower, then I can prevent any light leakage. Near plane, that is relative to your camera, and what kind of near plane you have for your shadows, and when they're calculated. Cookies are a type of texture that you can add to a light, that can be projected down. So if you have some sort of light that has a texture, maybe it's like a grid or something like that, uh, you can use that as a cookie on the light. Now, since this is a directional light, it is filling the entire scene because it's like the sun. If this were a spotlight, then it would be confined to the area of the cone's angle of that spotlight. But again, since this is a directional light that fills the scene like the sun would, it keeps a pattern of those cookies. And you can change the size of those cookies. So, I can project that particle alpha over and over and over again if I want, which is kind of cool. Draw halo. That is if you want any type of haloing happening around your light, you can turn on draw halo. Flares, if you import a flare package, you can add a flare onto lights or onto the sun. So then if you look at that light, a flare pops up and just adds a little extra pizzazz to your scene. Render mode, important, non-important. That is for the scene to know whether or not it needs to take more active measures for engaging with that light, depending on how far the player is from it. Culling mask, this is if you have objects that are on other layers that you do not want the light to interact with. You can actually put them on separate layers. So say I don't want the light to affect objects on transparent effects layer. And I take this pillar and I add it to transparent effects layer. Now you can see that the main light actually is not interacting with this object anymore. So that can be really useful for efficiency, or when it comes to light baking and you want some of these lights to avoid other ones, it may be useful. So other lights that Unity has under Game Object, Light, there's a point light, and that's just what you would expect it to be, a floating orb of light. And again, like the directional, you can change its color, but it has this function on it called range, and that is basically limiting how far out the point light can affect. So this is good for areas of interest or objects that you might interact with, in limiting some of how that light may be dispersed throughout the scene, so it's not trying to project it on everything way far out. It might be kept close. But it can also be great for changing the range. If you want to do like a warning signal where it's flashing, you can actually animate the range, or you could animate the intensity depending on what you want to do. Again, indirect multiplier, same thing as the directional. Shadows, if you want hard or soft shadows, the light can also cast those. Cookies, draw halo, everything that's the same as that directional light. There is also the spotlight, which serves like any other spotlight that you might see in any of the other 3D software packages. You can change its range, which is how far it will influence, and the spot angle, which is the width of that influence. And then everything else is the same as the other lights. Again, these can be really great for using these cookies. Oh, I need to have that set to clamp. But with spotlights, you can use all kinds of different cookies to get some really interesting shapes. If you're in some sort of jungle level, maybe you have like a canopy overhead leafy pattern that gets projected to the ground, like little bits of sunlight is peeking down through the trees or something like that. There's a lot of applications for these types of lights. And the last type of light is an area light. And area lights are only used for baking. So if you are baking any of your lights and making light maps to be more efficient with your level, area lights are great for all kinds of different things. Windows, they're great for bounce lighting, doing a type of area ambience. Um, they're a very versatile light, and again, they are only used for baking, which we will not be going over in this tutorial. There are other options in here as well, reflection probe and light probe. Those are two things done for a lot of efficiency. We will not be going over those in this tutorial, but I will be making another tutorial that will get to items such as reflection probes, light probe groups, and light baking. So I hope that this explanation of how Unity's basic lighting system works helps you out, gets you moving on making your game faster, more efficiently, more effectively, and yeah. So thanks for watching. If the video was helpful, please like it, and stay tuned for more. Thanks.